Okay, you guys, here's the notes for 12.6 surface area of cones. So the first way that you draw a cone is, I like to kind of draw an oval, but I like to draw like the smiley face of the oval first, and then finish it off with your dotted line because that's not the part that you would see. And then just put a dot at the top. This is your vertex up here. And this is your base down here. Now, those are just the things that you should be aware of, but even more, those aren't the things that we'll use in our formula. Those are just some vocabulary words that you need to know for a cone. So for our formula, and I'm going to redraw a cone and label this one. Before I draw the vertex and confuse you guys with that, this is our base. So from the center of our base out, that would be our radius. Then you have from your vertex coming down, this would be your height. But we don't even use that for the formula. So what we do use is this. Now if you notice right now, this would make a right triangle. So the regular height with what we call the slant height forms a right triangle. So that means you might have to use the Pythagorean theorem if they gave you the height. Otherwise, you would be using the radius and just the slant height. So the formula for the surface area of a cone, we have to first look at our lateral area. Now, if you imagine it that this cone is open and I could flip it around and have an ice cream cone, that would be the lateral area part. It doesn't include the base. So the lateral area, the formula for that is pi times your radius times your slant height. And then for your surface area, you would get the pi times the radius times the slant height and add only the area of the base, one base, and the base is a circle, so that would be pi r squared. Okay, so we're going to look at an example. Let's say that we are given the radius here of 4.7 and 13.6 for our slant height. Now, the picture draws the height, but for this I have just what I need for my formula. So I'm going to plug it in. I'm going to find my lateral area, which is pi times 4.7 times 13.6. And for that part, I'm going to use my calculator. And I'll just plug it straight into the calculator just like that. Pi times 4.7 times 13.6, enter, and I get 200.8. So I have 200.8 units squared, and then my surface area will be the 200.8 plus pi 4.7 squared. So once I add that in, I'm going to end up with 270.2 units squared. Okay, now I'm going to show you an example of what you might see in your homework where it gives you the height. So let's say that they give you, and I'm going to make this one easy, but let's say they told you our radius was 3 and our height was 4. So that means that we're going to have to find the slant height here. So you'd use your Pythagorean theorem, 4 squared plus 3 squared equals the slant height squared. And you guys are probably noticing that why is Mrs. Girardi even putting this into the Pythagorean theorem? Because you recognize this as a Pythagorean triple. So we know our slant height is 5. So that's 5 there. And then we're going to just plug it in. I'm going to just find the surface area on this one. So for the surface area, I'm using pi RL plus pi r squared. That's equal to pi times 3 times my slant height of 5 plus pi times 3 squared. And you can see this is 15 pi plus 9 pi, which is 24 pi. And you can leave your answer that way or plug it into your calculator and get 75.4 units squared. Okay, there's going to be some more complicated ones on your homework, but I'm going to show you something that's not quite as complicated, but there are some that, like 19, 20, and 21, you're going to have to use your brain a little bit, but you guys will do fine on that. One thing I do want to point out is T is the same as surface area. So let's say that we are looking for number 17. And this is really good for what I'm doing right now, is really going to be what you're using for 13 through 18. But I'm showing you number 17, which is part of your homework. So I'm not going to finish this one for you guys. I'm going to show you how to set it up. So it tells us that T is equal to 359 and that the slant height is equal to 15. So that means that 359 is equal to pi r times 15, and they want us to find the radius, plus pi r squared. And now you can see that this problem is turning into, since we're looking for the radius, we're going to be trying to solve this quadratic. So I'm going to divide everything by pi. So 359 divided by pi is 114, and that's equal to 15r plus r squared. And now I'm going to subtract 114 from both sides and rewrite this right side. So it's 0 equals r squared plus 15r minus 114. And you're going to either use the quadratic formula, or if you can find the factors to make that work out perfectly, you use the zero product property. So right here, let me just show you guys this part again. You're wondering, how did I get from here to here? I subtracted the 114, and then I have these three terms that are on this side. So all I did was rearrange them. The r squared is right there, the 15r is right there, and then a negative 114. Okay, so those are your notes for 12.6, and you guys can start on your homework, which you'll have time in class to do tomorrow, which is page 668, number 7 through 21 all. Thank you.